When you're ready, we can work on in-class exercise 3.2, two-way factorial ANOVA together. First, we form hypotheses. We have two groups, therefore we can form two main effects. Hypothesis 1 is about the main effect of processing level. The null hypothesis is mu counting equals to mu rhyming equals to mu adjective equals to mu imaginary and equals to mu intentional. The research hypothesis is at least one group mean is different from others. Hypothesis 2 is about main effect of the age groups. The null hypothesis is mu old equals to mu young, and the research hypothesis is mu old does not equal to mu young. Then we have the third hypothesis, the interaction effect of processing level and age group. This is new. The null hypothesis is processing level does not interact with age group in predicting word recall. The research hypothesis is processing level interacts with age group in predicting word recall. At step 2, we run two-way factorial ANOVA with SPSS. As you can see from the table, we have 10 cells. Each cell has 10 participants. First, we need to enter the data. You can continue data entry to the data set for the one-way ANOVA. We need to enter the dependent variable factor 1 and factor 2. Then we need to label factor 1 and label factor 2. Here is how the data view page looks like. You should have a column of word recall, a column of process level. It should have values of 1, 2, 3, 4, 5, and the third column age group, it should have two levels, 2 and 1. This is how your variable view looks like. You should have word recall, process level, and age group. For process level, you should code the numbers into values. Then for the age group, you should code 1 as young and 2 as old. After you finish the data entry, you can run two-way ANOVA. Go to Analyze, then click on General Linear Model. Click on Univariate. Put your dependent variable into dependent list. Put the factors into fixed factors. Then click on Model. Here you need to test the full factorial model. This is a default. You don't have to do anything. You can just take a look. Then click on Plot. Put the processing level to a horizontal axis. Then put the age group to separate lines. Click on Add, then click on Continue. Finally, you click on Options, check Descriptive Statistics, Estimates of Effect Size, and Continue. You should have the SPSS output. I go directly to the ANOVA source table. This is the test of between subjects effect table. At the first column, you see the source. They are labeled correct model. Intercept, process level, age group, process level, times age group, error total, and the corrected total. You don't need to have intercept and total. So you can ignore those two rows. And this becomes clear. The first row is SS cell. This is analogical to the SS between in one-way ANOVA. But SS cell includes three parts: SS process level, which is SSA, SS age group, which is SSB, and SS process level times age group, which is SSA times B. The arrow line presents SS within. Then the last row is the SS total. So SS cell is 1945.49. It includes three components: SSA 1514.94, SSB 240.25, and SSAB 190.30. If you add these three numbers together, you will have SS cell, which is 1945.49. Then SS within is 722.30. If you add SS cell and SS within, you will get SS total, that is 1945.49 plus 722.30 equals to 2667.79. Now let's move to the column of DF. DF cell is 9. It is 10 minus 1 is 9. DF process is 4. Is 5 process levels minus 1 is 4. DF age is 1. Is 2 age groups minus 1 is 1. Then DF process level times age group is 4. This is 4 plus 1 is 4. So DF AB equals to DFA times DFB. 4 equals to 4 times 1. Then you have SS error of 90. SS total is 99. As you can check, 99 equals to 9 plus 90. Now let's move to mean square column. Mean square cell equals to 1945.49 divided by 9. It is 216.17. Mean square process is 1514.94 divided by 4. It is 378.74. Mean square age group equals to 240.25 divided by 1. It is 240.25. MS interaction equals to 190.30. Divided by 4, it is 47.58. Finally, MS error equals to 722.30 divided by 90, it is 8.03. Finally, let's look at the F column. The F test for the effect of cell equals to mean square cell divided by mean square error. It is 216.17 divided by 8.03, so the F score is 26.94. It was significant. The partial eta square is 0.73. If you look at the main effect of process level, the F score equals to 378.74 divided by MS within, which is 8.03. So the F test for the process level is 47.19. It was significant, and the partial eta square is 0.68. Now let's look at the age group. Mean square age group is 240.25. The F score for the age group is 240.25 divided by 8.03. It is 29.94. It was significant. Finally, the F test for the interaction effect equals to MS interaction divided by MS error. So it is 47.58 divided by 8.03. The F score is 5.93. It is also significant. The effect size was 0.21. This is SPSS between subject effects table. We need to hand calculating the ANOVA source table. So basically, we can transform this SPSS table into the ANOVA source table. This example, the main effect of processing level was significant. The main effect of age group was significant. The interaction effect between processing level and age group was also significant. We can present these effects in the interaction plot. As you can see, the x-axis presents processing level for both blue line and the red line. People who had deeper processing level tend to memorize more words than people have the light level of processing. That indicates the main effect of processing level. If you look at the second factor, age group, the blue line presents young group and the red line presents old group. You can see that averagely, young people tend to remember more words than older people. Finally, you can see these two lines, or two curved lines, are not parallel to each other. There is an interaction. When they both processed word at a lighter level, like counting, there isn't much difference between young and old groups. However, when they had deeper processing, such as in the adjective group, imaginary group, and the intention group, it seems like young people record more words than older people when they both engage in deeper level of word processing. That is called the interaction effect. The number of words recorded not only depending on the processing level, but also depending on the combination between the processing level and the age group. Finally, in step 5, you should report the results in APA style. The two-way ANOVA was conducted to investigate word recall in processing level conditions and age groups. There was a significant main effect for processing level condition. F490 equals to 47.19. P is less than 0.001. Partial eta square is 0.68. And age groups, F190 equals to 29.94. P is less than 0.001. Partial eta square is 0.25. The interaction between the two factors, that is, the processing level and age group, was significant. F490 equals to 5.93. P is less than 0.001. Partial eta square is 0.21. This is two-way factorial ANOVA. I'd like to review the general linear model for both one-way ANOVA and two-way factorial ANOVA. Remember, for one-way ANOVA, x equals to mu the ground mean plus tau j the group effect plus error, the error term corresponding to that particular subject. For two-way ANOVA, the GLM is more complicated. To predict an individual score, x, I, j, k, it means the kth person in the I processing group and the j age group. That person's word record score equals to mu the ground mean plus alpha I, the effect of the processing level, plus beta j, the effect of age group, plus alpha beta ij, the interaction effect of processing level and age group, plus the error term specific to that individual. So this is the two-way ANOVA general linear model equation. These equations are also called a structure equation. If we are good with this concept, let's do another exercise. You can go to Canvas to find out in-class exercise 3.3 and start working on this two-way factorial ANOVA question. After you finish, you can move to the last class video, and we will go over in-class exercise 3.3 together.